Okay, now we're going to look at solving a system of linear equations in two variables, right? So they've got an example here, 2x plus 3y equals 6. This is the solution for that equation. But if I have another equation, here's the solution for it. And if I have a system, in other words, these things have to be considered at the same time. They're related equations to whatever situation we're talking about. Then what happens is the solution for the system is that point where those lines intersect. In other words, this point right here is on the blue line and the red line. Okay, so now notice a couple of things. One thing is, hey, I'm back to just one answer, right? The reason we had to start drawing these lines is because we had an infinite number of answers. But now I'm back to one answer. So while we could graph each line individually and see where the intersection point is, okay, look also at the problem with that. Ugh. What is that? Is it 3.5 negative 1/2? Is it 3.6 negative 0.55? You know, I really can't tell. If they don't intersect at a grid mark, I don't have any way to tell what that answer is. So while this is a good way to see what it means to be the answer to a system, it's not a good way to find the answer. Okay, and once again, since we're back to our answer being one point instead of an infinite number of points, we don't really have to draw a picture of it. Okay, now before we move to the others, think about something else, a couple of things that can happen with a system of equations. You might have two lines that never intersect, right, if they're parallel. So if they never intersect, there's not going to be a point that's on both lines, and so we're still going to get a possible no solution. Or what if in reality, when we graphed it, it was really just the same line on top of each other? Then we're going to be back to having an infinite number of answers because every point on the line would satisfy the entire system. Okay, so we'll talk about those as we get to it. All right. So there's the steps for solving a linear system by substitution. That's going to be our first method, right? And then next time we'll look at another method, okay? But the first method is substitution. So you can pause it and read over those steps if you want, but I'm just going to dig right in and explain how to do it. All right, so notice we have a system, which is two equations, okay? And in order to be a solution to the system, I need to find a value that solves this equation while also solving this equation. Okay, so the substitution method means I need to take one of these equations and solve for one of the variables. Doesn't matter which equation, doesn't matter which variable. However, hopefully we notice, hey, one of these equations is already solved for one of the variables. Okay, so my problem with either of these equations is I got two variables, so I can't solve that other than draw a picture of it, right? There's an infinite number of solutions. I can't solve an equation unless it just has one variable in it. But if I know that x equals 3 minus 2y, x is 3 minus 2y, let's change that x to 3 minus 2y. It's the same thing, right? X is 3 minus 2y. So I'm going to take this original problem, I'm going to say 2, but instead of times x, I'm going to say times 3 minus 2y, because x is 3 minus 2y. Finish your equation, plus 7y equals negative 12. And notice now, hey, we got an equation with one variable in it. So I can solve this thing. Okay, now let's look one more time. This is 2 times x plus 7y equals negative 12. 2x plus 7y equals negative 12. Okay, distribute to get rid of those parentheses. So 6 minus 4y plus 7y equals negative 12. Now it's just, we're back to just solving a regular linear equation with one variable. Okay, simplify each side, do any math you can do, combine like terms. So 6 plus 3y equals negative 12. Okay, when there's no math left to do, all my y's are already on the same side, so undo anything being added or subtracted to the variable term. So 3y equals negative 18, and then undo anything being multiplied to the variable term. So y equals negative 6. So once I know what y is, then I can just take it and plug it into, it doesn't matter which equation, but hey, this one's already solved for x. The math would be a lot easier if I plugged it into this one. So x is 3 minus 2, y is negative 6. So x is 3 plus 12, x is 15. So x is 15, and y is negative 6. Now, if I want, I can plug it into both equations. This value, and notice it's an x and a y, so this point has to satisfy both of these equations. And if I wanted to go in and check, I could do that. Okay, so that's all there is to the substitution method. Okay, I'm going to take one of these equations and solve for one of the variables. Now, let's try to make our math as easy as possible. So I'm going to take this first equation and solve it for x. If I took one of these and tried to get x or y by itself, I'd make fractions, because at some point I'd have to divide by 2 to make 1x or 5 or negative 4. But hey, this one, I can take this equation, right, and just subtract 1 from both sides and have x equals negative 4y minus 1. Now it's just like that other one we did. Let's plug it into the other one. I can't plug it back into the same one. I wouldn't get anywhere that way. Just be chasing my tail, right? So plug it into the other equation. So the other equation says 2 times x, but x is negative 4y minus 1. So 2 times negative 4y minus 1, it's the same thing as saying 2 times x, minus 5y equals 11. Now I have an equation I can solve. It just has one variable in it. Let's get rid of parentheses. Negative 8y minus 2 minus 5y equals 11. Simplify, combine like terms. Minus 13y minus 2 equals 11. Okay, let's add 2 to both sides to get minus 13y equals 13, and divide by negative 13. So y equals negative 1. Now, don't forget, I need an x and a y. So I've got to go back and substitute in. And hey, I'm going to substitute in right here where I've already solved that for x. So x is negative 4 times y minus 1, or 4 minus 1, 3. Y is negative 1, x is 3. Okay. Notice this one already has one of the equations solved for one of the variables, so I can just plug it in right away. So 16x minus 2, but instead of y, y is 8x plus 4, and then equals 8. 16x minus 2y is 8. Let's distribute. Okay. Uh-oh. Remember from before, if all of our variables went away, we said that means one of two things. Either there's no answer or there's an infinite set of answers. Same thing here, exact same thing. If you're working the problem and your last step is x equals a number, you're good to go, keep going. But if your variables disappear, that means either there's no answer or there's an infinite number of answers. And if you get something crazy like this, -8 does not equal 8, that means there's no solution. We call this an inconsistent system. It's inconsistent. It doesn't make sense. I can't make -8 equal 8, right? That's inconsistent. And your answer is no solution. That means that's two parallel lines. They never ever cross. Okay. Which variable do you want to solve for here? Yeah, I would solve for that x right there. All right, so I'm going to subtract 3y from both sides. So x equals minus 3y minus 7, right? Now I'm going to sub this minus 3y minus 7 in place of that x. So we have 4, but instead of times x, x is -3y minus 7. And then finish out the equation, plus 12y equals -28. Okay, now I have one variable, so get rid of these parentheses, -12y minus 28 plus 12y equals -28. Hey, look at this again. If your variables disappear, it's either no solution or an infinite solution. Now this one, we got the same thing on each side. -28 equals -28. It always does. We call this a dependent system, right? They're dependent on each other. They're the same line is what that means. They're really the same line. So the way we're going to write our answer. Now I think your MyLabs Plus already has this part for you, but you're going to need to remember that for your test. Okay, so these braces are read the set of all x, y such that. Everyone is going to start that way. And then you just take one of these equations and write it in there, right? So such that x plus 3y equals -7. In other words, anything that satisfies that equation will satisfy the entire system, because those are really the same two equations. Look what would happen if I multiplied this top one by 4. 4x plus 12y equals -28. Oh, it's the same equation. Okay, or divide this 4 out. X plus 3y equals -7. It's just really the same equation. All right, one more. Okay, don't let those fractions freak you out. Why? Because look, we have equal signs. So get rid of your fractions. I'm going to multiply everything in the top one by 6 because that's the least common denominator. Okay, that means 6 divided by 2 is 3. So now I have 1 times 3x. Here 6 divided by 3 is 2, so 1 times 2y. And here 6 divided by 3 is 2, so -1 times 2. Okay, same thing here, except I'm multiplying everything by 2 because that's my only denominator. So that'll divide out and leave 1x. This is plus 4y equals -4. Okay, so now I have a regular looking system. So don't let fractions and decimals, freak you out. If we have an equal sign, we can get rid of them. Okay, all right, I'm going to solve this equation for x. That's going to say if I subtract 4y from both sides, I'm going to have x equals minus 4y minus 4, right? Subtract 4y from both sides. Okay, and then plug it into the other equation. So 3 instead of times x, because x is negative 4y minus 4, 3 times negative 4y minus 4, 3x plus 2y equals negative 2. Now we have an equation in one variable. We can solve it. Let's get rid of these parentheses. Negative 12y minus 12 plus 2y equals negative 2. Combining like terms, negative 10y minus 12 equals minus 2. Undo everything being added to the variable. So let's add 12y. Just 12 to both sides to have negative 10y equals 10. Undo anything being multiplied to the variable. So y equals negative 1. Okay, and the easiest place to plug it in is right here. If y is negative 1, then x must be negative 4 times negative 1 minus 4. Okay, so x is 4 minus 4, or 0. Y is negative 1, x is 0. Okay, so practice those, and then next time we'll look at another method, just a different method to solve the same kinds of problems. Okay.